Hello class, today we'll talk about section 2.2, functions and graph. We have 4 objectives here. Determine whether a correspondence is a function. Given a function described by an equation, find function values, outputs. For specified values, inputs. Draw the graph of a function. Determine whether a graph is that of a function using the vertical line test. So those are the 4 objectives we'll talk about. So here's the definition of function, domain, range. A function is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to exactly one member of the range. So, and if you want to think about real-life applications, you can think of, given a student, there is just one student ID, right? You won't have 2 student ID. Another example is, given an item, there is just one price. So, given an item is the domain. There's just one price is the range. And the previous example, we'll talk about, given a student, which is a domain, there is just one ID, which is the range. So, input, output. Input is domain. What is output? Range. Here's the example. Determine whether the correspondent f is a function. This correspondent f encompasses all these. Okay, this is f. And given the domain are 1, 2, 3, these 1, 2, 3 belong to this domain, and the range is 60, 10, and 5. Okay? And the question is, determine whether the correspondence between these correspondence is a function. So if you follow this definition, right, it say that each member of the domain corresponds to exactly one member of the range. So for this member right here of the domain, how many member that it maps to in the range? There's only one, right? Look at this one right here, pointing only 60. 2 right here of the domain pointing only to 10. This member 3 of domain pointing to only 5. So it satisfies this definition. Thus you say that yes, f is a function. Yes, f is a function. Okay? Now, here's another example. Determine whether the correspondent g is a function. So this correspondence for g, its domain is 25, 30. Its range are 60 and 10. Now, the question is, determine if g, the function g is a function. Sorry, determine g is a function. So again, we follow the definition. Each member of the domain should only correspond to one member of the range. So let's start with 20. How many member it maps to in the range? There's only one, right, which is 60. That means it's good. How about 5? How many? 60, right? So it's maps to 60 of the range. So only one is good. How about 30? 30 maps to 10. So only one member of the range. So yes, it's good. Therefore, you say solution. Thus, g is a function because each of its members match only to one member of the range. And the last example I have, same question, so I'm going to erase this, okay? So the question is, range right here. Determine whether the correspondence h, this time it's called h, okay, not f, h, and h 155 are the domain, and range 60. 10 and 2, and 1 corresponds to 60, 1 also corresponds to 2, and 50 corresponds to 2. Okay? So, same idea. Let's start with 1. How many members this one in the domain maps to the range? It maps to 2, right? Uh-oh, that's not good. The maximum, or the most, it can match to is only 1. So, because this one right here already showed that it maps to more than 2 members of the range, so we'll say that thus this corresponding h right here is not a function, because one member of its domain, this one, maps to 2 members of the range. It does not satisfy definition of the function domain and range. Okay, this number 5 right here it's fine because it only maps to 2, but it does not satisfy because one member right here of the domain maps to 2 members. So h is not a function.